Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, we're not going to have another Tandy video. I'm wearing my Beagle Brothers shirt because on today's video, we're going to be taking a look at this, an original Apple II. No, not an Apple II Plus, but an actual original Apple II. This machine belongs to a friend of mine and he had it stored away and he wasn't sure if it even worked, so I thought I would check it out for him and run it through its paces. So without further ado, let's get right to it. So, the original Apple II. Isn't it nice? I'm petting it. Yeah, it's not a Commodore PET, but it came out at the same time as the Commodore PET, 1977, around the later part of 1977. It was one of the, triad of machines. The Apple II, invented, of course, by Steve Wozniak. Then there was the TRS-80 Model 1, which I've recently shown on the channel. And then we also have the Commodore PET 2001-8, which I am lucky enough to have as well. Now, I've only just seen original Apple IIs because these machines didn't last very long in the market. They were relatively quickly replaced with the Apple II Plus, which has a very similar badge to this, except of course it has a plus written underneath it. The two, like this one, and the Plus are very, very similar machines. In fact, they're basically identical, except the Plus was really only a change with the ROMs on the motherboard. I'm no expert in Apple II versus II Plus differences, but I'm aware that the keyboard on the earlier machines has this raised power key like this one does, or it's not a key actually, it's just a power light that was then flush on the Apple II Plus. But also these keys have a very shiny appearance to them, and I must say, for a computer that's as old as this, it's probably from either 77 or 78, this thing looks absolutely mint condition. Now, the history of this exact computer, I don't really know much about. We'll take a look at the serial number in a second to see where it kind of falls in the line of Apple IIs. But my friend actually rescued this from getting put in the trash. Now, this was a number of years ago, and nowadays, I'm not sure if that would happen exactly, but at the time he found this, it was basically slated to be e-wasted. So yeah, it got saved. That's pretty cool. It was the original Apple II that kind of had this wedge shape to the case that carried on all the way into the Apple IIe, which was manufactured, I think, into the 90s. So you definitely saw this design for quite a while, although the case itself is a lot more sturdy on the original Apple II Plus and the Apple II like this. The Apple IIe kind of went to a more plastic design. This particular example is not blemish-free. There's like a little tiny dent in this metal badge here. I think there's the odd tiny little scratch. But I haven't really cleaned this thing up. This is basically how I got it from my friend, and it was just stored in his storage unit for who knows how long. So it's quite amazing how nice of a condition this particular computer is. You may have seen the Apple II Plus videos on my channel where I restored one of those machines, and one of the things I noticed is that the keyboard on my II Plus is an Alps keyboard, and I don't know who makes this keyboard, but it's absolutely not Alps. And while it's okay to type on, it's not a very nice feeling keyboard, especially compared to the Alps board. If you push these keys on the edge here, they sort of bind up a little bit, while the G key does. That may of course be that there's just dirt inside of here, and I'm probably not going to be taking this thing apart to the level of cleaning the keyboard out, because as you can see, like the keyboard looks like it's in absolutely perfect shape. Let's take a quick look at the rest of this machine here. The side has a little bit of adhesive on it that I haven't cleaned off. I think that should come right off. There's nothing much to report on the back of the machine. It looks exactly like the II Plus. It does have like this gold looking power supply, a little bit of grime right here where someone has reached around to activate the power switch a bunch of times. The other side of the machine is blemish free, just a little bit dirty. Looking at the top, there's that Apple II badge and there's that little dent. You can see it's right there as I flash the light across it. Otherwise, amazing condition. I guess there's a little scratch right here in the plastic. It's not gonna be perfect. It's an old computer. Looking at the bottom of the computer, there is the serial number A2S1-14230. I'm pretty sure these are kind of sequential. So 14,000 Apple II ever made, and not sure how many were actually made if you count all the different Apple IIs, but millions and millions and millions. So kind of neat to have something that's relatively low in the scheme of things. I have the lid of the computer off, and one of the things is that the little Velcro pads, or I don't know, whatever these little hold down things have come off. The adhesive has come off here and here where originally it was stuck down. Now luckily, these are the original ones, and if I pull that apart, looks like that. It's not hook and loop, it's not Velcro, they're plastic. Now the question is to all the Apple II fans out there, what is the right way to, let me push this back on, it clicks on, there we go. What is the right way to re-adhere these down to the case so that this lid can be held on again? I ask because these hold on so tightly that if I just use any kind of adhesive that's not strong enough, it's just gonna rip right off the first time I try to remove the lid from this computer. Well, let's take a look on the inside of this machine. So there it is. I haven't really touched this or done anything with it. There's this random yellow wire that goes under the keyboard somewhere. And I can notice that one of the RAM chips is missing right here, which means that it probably had a language card in here at one point, probably allowing it to run AppleSoft Basic. These are the ROMs here, and a couple are missing. I think that's pretty typical. I think this thing has Integer Basic, which is a basic that Woz wrote, and then later AppleSoft Basic, which is Microsoft derived, came later. Now with the language card, you take this chip out and you put it on the language card itself, and the language card has an additional 16K, and the card pulls the refresh signaling for the DRAM off of the motherboard, and then it refreshes the RAM on the card. It was a way to simplify the logic required for the language card. Pretty smart design, to be honest. Again, if you're familiar with the Apple II Plus or you watch my videos on it, the motherboard is really basically the same. There's just minor revisions from motherboard to motherboard between the different Apple II and II Pluses, but really, there is no actual difference between an Apple II Plus and an Apple II other than ROMs. So this could be converted into a normal Apple II Plus if you just put the II Plus ROMs on this board. There is something written up here, 7901. I don't know if that's a date code or if that's a serial number, but yeah, 7901, whatever that means. The power supply that's in this machine is gold, and there's a number and there's another number. I have no idea if this is like the original one or replaced. All the power supplies from the Apple IIe, II Plus, and II are interchangeable with each other. They have the same power connector. So someone may have swapped that out before. Here's something interesting that is not on my Apple II Plus, and it's these blocks here that say 16K on them. I'm pretty sure that this motherboard supported both 4K DRAM chips and 16K DRAM chips. So there are currently 3 banks of 16K, giving you a total of 48K, but you could also have 4K DRAM in here, and I think these little blocks would say 4K on them instead, and that of course would give you 12 total K of memory for your Apple II. Now I am pretty amazed at how clean this computer is on the inside considering the age of this thing. So wherever this computer was stored for its life, it was in a very dust-free environment, or maybe it was covered up or whatever, because basically looks near mint in here. I mean, there's really no dust in here, and that's pretty amazing to me. Now we're gonna have to take a look at this in a second, but I see some mods going on here. The keyboard itself is the single board type, which I think is normal for the original Apple IIs, but there's some board that's floating here, and then I see a couple ICs stacked and some bodge wires there. And I think that this wire here goes to the keyboard. I wouldn't be surprised if it goes to the shift key, and it probably was for some lowercase mod that was on this, which I think uses one of the paddle inputs so that the software you're running knows you're pushing the shift key to give you lowercase. It is obvious to me that this computer had a bunch of expansion cards in it, and those were taken off at some point. Maybe when this computer was put out of service, maybe something died on here and they took those cards out to use them elsewhere, and then they just left these wires and things in here and clearly didn't even put back that extra RAM chip. So I'm really dying to know if this computer actually works or not. Now there's a good chance if it was put out of service, maybe the power supply has died. So I think for my initial testing, I'm gonna unplug the power supply here, and I'm gonna get a known good power supply because I have a couple spares. Not this one that's sitting right here, because someone has gone ahead and cut the connector off that one. I'm gonna grab a known good one and a monitor, oh, and a RAM chip. Let's see if we can get this thing just working. I wouldn't be surprised if this computer just works perfectly, and maybe this power supply is the problem. All right, for testing, I'm gonna use a good old composite monitor. This is my test Apple IIc monitor that I use for everything. I really like this thing because it has a handle on it. It's so easy to move around. So this is the one I keep around for convenient testing. And then for video output, this is the composite jack right here, and it's accessed on the back of the computer. I'm just gonna use this old gray cable, which would have been time appropriate for this. Now that jack is very crusty, but it doesn't seem loose. I think that can go loose sometimes, and that can cause video output problems. Here's the power supply that I'm gonna use. It has a check mark on there. I have a QC sticker on there for myself and a new X cap from April 2022. So absolutely, positively functional power supply. Alrighty, here we go, the moment of truth. definitely powered up, and you see there a little flash of something. But the computer is definitely no beep, no happiness. Now the surprising thing is the video output circuitry on the Apple II is always running. It's not like it has a CRTC that has to be set up by the ROM or the processor. So just turning on the computer should result in an actual picture, and it should be garbage. And that's even if you pull the CPU and the ROM out, it should be running. So I guess this video has turned into a repair video. For disassembly of an Apple II, you do have to flip it upside down. So we'll be using this because I don't want to possibly add any additional scratches to this very, very old computer here, and potentially valuable one. The top part of the cover is held onto this metal base with screws around the perimeter. So all you have to do is simply remove these screws and then it comes right off. All right, with the screws out, you just have to carefully hold the thing together, flip it back over, because of course the top part is now loose, and the thing is the keyboard is connected to the motherboard. So when I lift this up here, you have to make sure that you unplug the keyboard cable, which is right here under this crazy board. You know what? This is the character generator, this little board here. So maybe this thing does have a lowercase mod in it. And you know, it's funny because I wonder if that's causing the problem with the video. All right, so there's the keyboard. And this is the cable that connects to the motherboard. It's very fragile, so you make sure you don't want to bend those pins. And as I said, see this wire here? It would be a shift mod. It is connected to the key switch, I think for the shift key. We have a date code right here. It says December 8, maybe, 1978 it looks like. Also in the top cover, you see this piece of Velcro right here. This would have been for an RF modulator. Apple didn't sell an RF modulator because of FCC requirements, so they relied on third-party companies, and it connected to the motherboard right there, and then typically people Velcroed it into the case there, and then it would have an RF connection, and you would run it out like one of these slots here to your television. All right, here's an up-close look at this little stack here. Well, first of all, you might be noticing this foam here around the speaker. That is actually normal. The way the speaker is connected, I think they put this on to dampen the vibration or something. I don't really know. Typically, the foam is very degraded. This stuff is. I'm not really going to touch it because it might fall apart. But this is the character generator right here. It would be normally on the motherboard. But instead, there's this stack here, which seems to be in there relatively well, but it's got 2 ROM chips on here. So maybe this is a lowercase mod, even for 40 column mode. And then when we look here, there's a couple baud wires that come off and they go to this IC here, which has a socket in a socket, and the chip has been removed from the motherboard. Now, we might have had no video output because of what's going on right here. This character generator is what's used even when the system is not running to draw the characters on the screen. If for some reason these aren't being selected, maybe that's why we're getting an entirely black screen. Although typically if you pull this thing out of the motherboard, if I recall, you get just a white screen because the data lines that are coming off these ROM chips will be floating. But if something is wrong with this, maybe that's causing it to just basically be all zeros, which would show up as all black on the screen. Taking a closer look at these, this one's from 1978, 23rd week, and this one's from 1977, 51st week. And then right here scratched into the board, it says 389. Is that some kind of serial number for this mod? Looking at the DRAM here, you can tell that these are 3 different types of DRAM, National Semiconductor. We have NEC in the middle bank, and these are Hitachi chip. But we have one NEC chip right here that has been switched out. So I guess maybe a chip went bad at some point and someone had to swap that out. Now looking at the date codes on the chips here, I see that they're sort of from all over the place, and that's very much like it was on my Apple II Plus. There was no rhyme or reason to the date codes, almost like Apple was just buying up whatever stock of 74LS logic chips they could get and then shoving them in the machines. Like here's one from 1976, 2nd week, and then 1978, 14th week, 1978, 31st week, 1978, 48th week, and these chips all seem to be 1978. This one over here is 48th week of 78. So I'm gonna say, like, if we find the latest chip that we can on here that looks like it's an original chip, that's probably when this machine was made, but they were definitely grabbing chips from all throughout the year 1978. Okay, well, looking around on here, everything appears to be in good order. I don't see any massive signs of corrosion. All the chips are in correctly in the sockets, that is. So I think it's time for the old split screen. And let's break out the oscilloscope and start looking at signals on this thing. I have the camera set up here at a slightly more oblique angle than normal because the Apple II monitor is here. So when this machine works, because it will work, we will be able to see the video at least here. It's not great because I really need a way to capture multiple things at the same time, and I haven't quite figured that out with OBS. Anyhow, okay, let's get to the troubleshooting. The best resource for troubleshooting these early Apple IIs, all the way up to the Apple II Plus, is absolutely, without a doubt, the Apple II circuit description, as seen right here. This book, written by Winston Gaylor, is absolutely phenomenal, has such a well-written description and thorough documentation of how the Apple II works. It really puts, like, the TRS-80 service manuals that I like to shame when it comes to how clear the descriptions are of how this thing works. You could basically understand every single thing there is to know about how the Apple II works by reading this book. Anyhow, we have the oscilloscope up. I have the probe connected here, which is ground. We have the probe ready. Let's think about what the first things you need to do when you have a machine that's not working, especially an Apple II, but this applies to anything. Well, we need to check a few things. You got to check that the power is good, right? First and foremost, you need good power. I don't need to worry about that. I have my known good power supply right here. I was using it the other day, so I'm very, very confident that that power supply is working properly. What are the next things you need to check? Well, you got to make sure the CPU is running, right? Clock signal, reset signal, and then activity on the bus. Now the thing is, I had mentioned this earlier, the video output circuitry on the Apple II actually runs on its own without the help of the CPU or the ROMs. What happens if the CPU and or the ROMs aren't working is when you turn on the computer, you're just going to see a bunch of garbage because really the video circuitry will display whatever's in the RAM when you first power on the machine. And typically that is just like a repeating pattern. If you've ever used an Apple II or a II Plus, when you first turn it on, you'll actually see that garbage for a split second. And then what happens is the CPU starts executing code once it comes out of reset, and then the ROMs will clear the video memory, the part of the DRAM, which is video memory, which gives you a blank screen with the banner at the top. If we think logically about what's happening with this machine right now, we have a couple symptoms. First of all, we're not getting the beep. So that indicates that the CPU and or the ROMs is not running properly. Next, we're not getting any video output whatsoever. Now, a couple things could cause that, of course. The video output circuitry itself needs to be working to generate or display whatever's in the RAM. But the fact is we have two symptoms at the same time, no beep, but also no video. And that sort of leads me down the road of no clock signals. Now, video circuitry on this thing is completely run by the master clock on the Apple II. It's divided down a bunch of times. There's a crystal oscillator right here. And that is what's running while the machine is not even running with the CPU. That is what's decoding the RAM to the video screen. So if the clocks are bad, you're not going to have working video display at all. And we're also not going to have any execution by the CPU or the ROMs. Therefore, we're not going to get a beep. Now, there could be plenty of other things going on that could cause both those problems. Like there might be multiple faults on this board, who knows. But that's a good place to start because no clocks right away will cause these exact symptoms. So first thing to do is let's bring up the 6502 pinout. Pin 37 is the clock input into the 6502, and the 6502 will generate a couple clocks, well, they'll come out of it, which are Phi 2 and Phi 1. And those clocks are used very specifically for chip select lines, chip select logic, also the way the memory interfaces to the CPU. In fact, I think I've talked about this before, but the 6502 is a pretty neat processor. And of course, it's based on the original Motorola 6800, which works in a very similar way. The fact that there are two different clock outputs there, Phi 1 and Phi 2, mean that a 1 megahertz 6502, which is what's on this thing, can actually operate a lot more efficiently than other computers. And that is specifically because the memory is only accessed on one of those two clocks, while the other clock can be used for the video circuitry on this machine to basically access the RAM to display those characters on screen while the CPU is not accessing the memory. With other systems where the DRAM is also running as the video memory, the CPU has to wait while the video circuitry reads the RAM. But because the CPU is only using the RAM basically half of the time, you effectively get 2 megahertz of RAM speed on a 1 megahertz machine like this. It's pretty cool, and Woz took advantage of that to make a very fast and efficient machine, which is how a 1 megahertz Apple II like this, if you've ever used one, doesn't feel that slow and terrible when it comes to the graphics performance and just the overall performance of the machine. Okay, I got off on a tangent there. Let's go back to this. So we're going to be looking for Phi 0, or the clock 0 input right here, which is pin 37. The notch is right there on the CPU, so that's pin 1. So pin 37 is going to be on this side. I'm going to start on pin 8 on the CPU just to check that we're actually getting 5 volts. And there we are, 4.93 volts, no problem. So that just validates that we're getting the 5 volts. If we didn't have 5 volts there, then yeah, maybe there's like a problem with the power connector, and that could obviously cause issues as well. Okay, so now I'm on pin 37. Let's look for a clock. We should see a 1 megahertz or like 1.02 megahertz clock here. And we are not. If I zoom out, nothing. It is just stuck at 5 volts. So right there, that is a big problem. We know we're not going to have an operating computer at all. Now, the clock on this thing is generated from this crystal oscillator here. I think it's like 14 megahertz and change. And then it's divided down by a bunch of ICs. So it's not to say that this crystal oscillator is bad. It could well just be one of these 74 DSLogic chips here that has gone bad. So let's go to the circuit description and let's find that clock generation circuit very specifically and figure out how this all works. Oh, one thing, incidentally, this book very accurately describes all the different versions of motherboards that exist for the Apple II. And after reading that section, this is a Rev 1 motherboard. The key differentiator between the Rev 1 and the Rev 0 is it has a 555 timer here for automatic reset when you power on the machine. And it also has a delay line or a delay circuit, so you get 2 additional colors in the high-res mode. I think it's the orange and the blue, which are possible on this machine, while the very earliest Apple II, the Rev 0, would only have the green and the magenta in the high-res mode. Also, because it lacks the reset circuit, every time you turn that machine on, I think it just crashes and you have to hit Control Reset on the keyboard to get the computer running. Oh yeah, and there's one other small difference between the Rev 0 and the Rev 1. The Rev 0 also has no color killer circuit, so if you're using that motherboard with a color NTSC monitor, you're going to have a ton of color fringing on all the text, even if you're outside of the graphics modes, while the Rev 1 and everything after that will kill the color burst signal going to the monitor, which turns off the color decoding on the monitor, well, not this monochrome one, but on a color one, so that you don't get the color fringing on your text. All right, here we are, page 197. In the book, we have the clock generation circuit for all revisions. There's the master clock right there, 14.318 megahertz. If that crystal's bad, hopefully I have another one. But let's not jump to conclusions. Crystal oscillators are very reliable. Let's assume that maybe this gate right here, well, we'll start there. Maybe this gate here on B2 is the problem. That outputs the 14 megahertz that goes to the video generation circuitry, and that's what I was talking about, how it divides that clock down and generates the color burst frequency and all the other stuff that makes the video on this thing work. So you notice here it says B274S86. Well, on the motherboard, there are numbers A, B, C, D, and so on printed on the edge of the motherboard, and then from here it's got 1 to 14. So we know that that chip right there that says B2 is B2, this chip right here. So you don't even have to like look for it. It's such an easy computer to work on. Besides the fact everything is in sockets, it's just like a cinch to get to stuff. Anyhow, these are the relevant pins. So pin 10 is the input for the clock and pin 8 is the output. Let's go right to pin 10 and turn this on, and look at that. We do have a clock. It's just what I thought, 14.2. That's a little low, but the oscilloscope on here is not the best frequency counter in the world, so let's just assume that is good. Okay, let's check pin 8, which is the output of the gate here, because this is just buffering. All right, and there it is, and we got 14.3 whatever megahertz. Okay, cool, so we know that that gate is working. So the problem with the missing clocks is further down the chain. Now, I haven't studied these schematics in detail, but I wouldn't be surprised, like this stuff here, it looks like this has to do with soft switches and ROM, RAM, video generator. Okay, stuff is kind of going all over the place. We know we're not seeing the clock on the CPU, but where exactly is it stopping? I guess we just have to kind of like keep going along the path here and just see where we're missing stuff. So let's go to B1, where pin 9 here is the input from the gate we had just tested that should be at 14 megahertz. Okay, so pin 9, yes, absolutely has the clock. So we know that the sockets aren't bad, like between those two chips. It is getting to that pin. Okay, I'm on pin 14, to video generation. There's a 7 megahertz signal as well, so that is working. Let's look at the microprocessor. This right here should be the clock signal going to the CPU, right? That's the phi 0 that I was measuring earlier. That's pin 7. And, whoa, Okay, I heard some clicking out of the speaker. All of a sudden, we do have a clock now. Let me turn on this monitor here, because what if this thing just started working? That just could be a dodgy socket right there. Look at that. We have a video signal. There we go. Check it out. Dodgy socket. Literally, I touched that pin. I didn't see anything on there, and I heard like some crackling out of the speaker. Let's turn this off and on. Yeah, so we're getting stuff now. All right, I'm gonna pull that chip out, and we're gonna deoxit that socket. How long has it been since I've said that? So looking at this IC, it looks okay. I don't see any like particular corrosion or anything on it. Okay, let's put it in there. Oh, look at that! Beep! It freaking beeped! Oh, I can't believe it. I mean, on the screen, I don't know how you can see it, but there's just some letters and it ended up at the machine language monitor. Now, is that what these original Apple IIs do? Huh. I could have sworn that they go to like the Apple II prompt, like it runs basic, but maybe not? I don't know. Somehow it seems that I wasn't recording on the camera, the bench camera. Honestly, I was like 99.999% sure I hit record on that camera, and it looks like I didn't. So to recap, I tested the clock on the CPU. We weren't seeing anything. So I went down to the clock generation circuit here. I was on B2, I think it was right here. And I saw the clock signal coming in and out of it. And then I went to this chip here, which is B1, and I looked at the clock output of that. And as soon as I touched the pin, I heard some crackling on the speaker, and then the computer came to life. So I took it out, put some deoxit in that socket, and now when we turn it on, it ends up at the machine language monitor prompt, and that may or may not be working properly. I'm not exactly sure. I haven't reinstalled this RAM chip here though, so I'm gonna grab a spare RAM chip, stick that in there, so at least the thing has a full 48K again, and I'll plug a keyboard into this thing, and let's see if we can get some life out of this thing. Okay, I went to my spare parts and I found this 4116 chip here. It's a National Semiconductor chip that matches the brothers that are in here, so at least it's all the same, and we just have that one replaced IC there. So let's see if that makes any difference. Now, it just goes to the machine language monitor as well. So I don't know, is that just normal again for these original Apple IIs? So I just grabbed this keyboard here. It's from an Apple II Plus. Stuart sent this to me, and it has an Apple computer PCB on there. And you see this thing has this encoder on here, which is how the later Apple II Plus keyboards are, but it will be totally compatible with this particular machine. This has really terrible key switches, and I have bad 6 on here, and basically 6 is no good. And unfortunately, after doing some reading with this particular type of keyboard, I don't think there's any way to really repair these. I tried my best, and I never got the 6 working. So we'll have to do some poking around the machine language monitor here without the help of the 6 key, which might be difficult because if I put a floppy disk controller in here, oh, I just put it in a different slot than 6. All right, I plugged the keyboard in and I went to turn on the computer and it seems to be broken again. Well, at least we're getting video on the screen and the keyboard is working, but no more beep. I just gave the chips a little bit of a push in the corner there by the clock circuit, and it just sort of came to life. And look, it is absolutely, the keyboard's working at least. Let's see, does the 6 key work? It does not. Also, something interesting and a little bit annoying is I have the Apple II Plus plugged into the RetroTink right now, and I'm getting no video. So I know that these early revs have a pretty non-standard video signal, and I wonder if the RetroTink is just completely unhappy with that. I need to think about how I can maybe make this work. What could make this work? I mean, the monitor is obviously okay with it, but the RetroTink is not. Well, I have my older RetroTink here. Maybe I should try this. Maybe this will be a little more forgiving. And that does not seem to be the case. Same thing is happening. I mean, at least it gives me a black screen. Oh, there were look, we see little tiny bits of video popping up there. Let's see, I must be able to have another solution. I'm gonna keep looking. All right, there we go. We actually have now an input. This is my kind of crappy SCART conversion box. I know you can't see it in the camera, but there it is. Gosh, I made a video about this a long time ago. Basically, this thing is an entire LCD television in a box. And instead of driving an LCD panel, it has an HDMI transmitter. So it converts from SCART or composite video input, stuff like that, to HDMI. And it does that by emulating a television. Thing is, it's very, very forgiving and it works quite well. The issue is it's laggy. Because it's like an LCD TV, it's got a lot of processing or whatever. So you do have some lag on it, and I can even feel that typing on there. But there it is. There's the video signal. Okay, so we have a working system. In fact, let's look at D00 and let's look at it. Whoa! Wait, what just happened? I ended up in integer basic. What? Okay, I'm very, very confused. So the normal square bracket prompt is the AppleSoft basic prompt, and this is the integer basic one. I didn't even tell it to go to D000. It's just somehow ended up in it. Okay, if I do that again. No, that's what I expected it to do. Now, normally if you were gonna run something, you would do G, I think. See, and it's just hanging because that ROM doesn't exist. I don't know what I did there that dropped me into integer basic and somehow corrupted integer basic. All right, I'm on Wikipedia looking at integer basic, and it says, unlike later home computers, BASIC was not the default environment in Apple I. Okay, it started in the machine language monitor. You pressed Control B and Enter. Was that the same on the Apple II, though? Well, I suppose we can try Control B, Enter. That just froze. The whole computer is frozen now. Let's power cycle it. I think we're stuck again with a non-working machine. Yes, we are indeed. Really think we have some dodginess going on this clock side of the computer here. There we go, that worked. Why is the border gray? Is the video level turned up too high? Yeah, maybe it is, I don't know. Weird, okay, anyways, Control B. That box is super annoying. Look at that, we're in BASIC. Adrian Black, it's freaking working, it freaking works. But it does seem very unreliable. And again, I think it's whatever's going on with this clock circuitry over here is, I'm just gonna hit enter here and I'm gonna tap on the board. Yep, the computer just froze. Definitely we have some shenanigans over here. And there we go, we have a non-working system again. That box is right in the way of the damn cursor. Super frustrating. Okay, I think I need to just pop those chips out and let's deoxit those sockets over there. All right, well, I took a little bit of a break from this, and when I came back downstairs, it's working again. So I think we just have some very oxidized sockets. And unfortunately, the sockets that are on this motherboard are just not the best quality. What I was gonna do is we're gonna write a little program to make the computer beep, parentheses. Good thing I fixed that 6 key or this keyboard wouldn't be working for me. Okay, the reason why I'm doing all this, by the way, is I wanna create a tone. There we go, solid tone. And now I can poke around the motherboard and see if it crashes. So far, so good. Now, of course, the machine will, if it crashes, the CPU needs to be running for it to be doing this. Well, and there we go. So I tapped on the RAM and that caused it to crash. All I really need to do, if we want to just, you know, see this thing crashing, is we'll just do a little routine here. Oops. And that should print a lot to Adrian. So how sensitive is the RAM here? So interesting, it's like weirdly crashy. I'm almost thinking at this point, I just need to take every chip out or pull them out slightly and just push them back into the socket. Oh, there we go, crashed again. See if I can reset. Reset's working, but it did pause execution. Whoa, oh, look at that, okay. So yeah, we've got some more bad connections, I think, over on this side. So, okay, I'm gonna go through the entire board with the chip puller, and I'm just gonna slightly pull each chip out, push them back in. Hopefully that should do the trick. Alrighty, I've gone through every chip. I feel that like just pulling it out of the socket a little bit and kind of reinserting it, I didn't pull them out enough where that the legs had come out of the holes. That just sort of can scratch away any little oxidation that's happening on the legs or in the sockets or whatever, and hopefully make this machine a little bit more stable from just random crashing. Let's see if it even still works now. It didn't Still doesn't work. I mean, at least we're getting a video signal, right? But yeah, I'm pretty sure we do not have. Okay, the computer reset. Yeah, unfortunately, I really just feel that this is flaky sockets all over this board. And let's poke around here. I'll just tap chips one by one. See if anything causes it to crash. Oh, I clicked. Bad branch. That chip right there. Can I start this again? Okay, here we go. Let's try again. Stopped when I tapped the CPU. So we're definitely getting some shenanigans over here in the CPU section. Let me take them out, maybe deoxit these sockets. In fact, that one looks a little crusty on the pins. It's a TI chip. TI chips do that. They kind of get extra crusty. Deoxit does help that out. Oh yeah, there it is. So it's very oxidized. I don't think it's like necessarily a problem, but that definitely happens with those chips. Okay, let's see. Did I make it worse? At least it's booting. Okay, here we go. Let's tap, tap, tap. Okay, so far so good. I'm just gonna do another session of tapping around the whole board, and let's see if we get any crashy. Well, I gotta say, I think this thing is stable now. I was tapping all around the motherboard. The chips are getting pretty warm, but it's no longer crashing at like the simplest little touch. So I think that did the trick. You know, the deoxit up here, deoxit over there in the clock circuit, and maybe just reseating all the chips. I do have a full 48K. I guess I should plug a disk drive controller in so we can run some diagnostics, right? But yeah, it's been running this basic program here, and it seems pretty stable. These things are true survivors, really well made. Look how old these chips are. Everything from 1978 or around there, and they all freaking work. Not a single chip is bad. Well, no Apple II is complete without a Disk 2 controller card, and I have a clone card from Jamco of all companies. Who knew that they made Apple II clones? And I also have a clone disk drive from, I don't know, but it's looks like an Alps mechanism or something like that, but it has the standard Apple ribbon cable. All right, so the computer is off. I'm gonna plug this into slot 6, why not? I mean, that's obviously the normal slot that people use. The disk drive is sitting right here on the desk, and one thing to keep in mind with these old systems like this, it does not auto boot the floppy drive. You have to drop into basic and then type PR number 6, or I think there's a command you can type in the machine language monitor to do it as well. I don't know that off the top of my head. Let's turn this on. Okay, there we are. Gonna press Control B for basic and then PR number 6. And there it is. The disk drive just accessed. Awesome. Now, hopefully my box of discs here, I have something that can run some diagnostics, but why don't we try Fat City, which is a game that I totally love. And to be honest, I don't know if it's gonna work on this because it might require 64K, but well, that's part of the problem as well, is that the graphics mode just don't work on this box. All right, there's the monitor, and we're not getting anything on it. So it definitely was booted there, it did something. Let's go out of here and type PR number 6 again. It sounds like it's loading normally, and then it just stops. All right, I have a disk here that says Apple II Cillin, as in penicillin, as in, I think this is a diagnostic software package. Okay, there we go, Apple Cillin 2, 1982, RAM test, ROM test. I should be able to plug this back in, and you should be able to see it on the capture. Alrighty, there we go. Let's do a RAM test, first of all. Memory cards, okay, well, let's try the high memory first. Boy, this box really struggles. Let me try turning the picture down. Okay, there's a little potentiometer on the board here. I just adjusted that down. Oh, we got errors, everyone. We got errors. So this could easily be why that the game didn't work, because the RAM is not working. Wow, these chips are so hot as well. The middle row is burning hot. These ones aren't that bad. Those are hot, but these are not good. All right, look, it's still testing here and it's okay again. So the bad RAM stopped at 7FFF. So we noticed the errors are starting at 4,000, and a little bit of calculation tells us that that is starting at 16,384. So this first set of RAM chips on the bottom here is the first bank of memory, 0 to 16K. Then this set right here is the next 16K, which starts at 4,000, and we noticed it errored out all the way up until 7FFF. And the top of 7FFF is what exactly? It's the top of this bank again. Okay, so I wrote 5 bytes to memory, and that did seem to work. Let's try again, but we'll put all zeros. And let's look at what we got now. 44. So because we had all Fs the first time I wrote, and then when I wrote again, all zeros, we got 44. That implies there are 2 stuck bits. It would be maybe this chip right here, and maybe this chip right here. I'm not sure the order that these are actually in the motherboard, so I'm just gonna pop those out, see if putting new chips in fixes the problem. Now, if I went and looked up the schematics, I could find out very easily which of the 2 chips that were on those bits, but being lazy here. All right, I've swapped out those chips now. Let's turn this back on and let's see what we get. 0, 0, 0, 0, 0, 0, 0, 0. I'm typing blindly here. And that did not work. I think I swapped out the wrong 2 chips. Here we go again. 4000, colon, 0, 0, 0, 0, 0, 0, 0, 0. Now, if I don't see any change, then, okay, there we go, it worked. Now, if you were working on a system and had RAM problems like this, what you should do is not do what I'm doing, and you should actually look at the schematics to figure out which data bit is stuck and which socket that is on the motherboard. I'm obviously being a little bit lazy here by just sort of swapping because everything is in a socket. It's real easy, but that would be the right way to do it. There we go. So 3 new chips in that bank, and there we go, FF. So it's storing correctly. Nice. Okay, so 3 actual bad chips so far on this thing. Just 3. Everything else has been so far so good. Guess these NEC chips are like the MTs of the 4116 type DRAMs. I'm sorry, this video is a little haphazard. I think I'm a bit all over the place today, but it's fun working on such a cool old computer, and it's so easy to work on. All right, I'm ready for some Fat City. It's got some music if this thing does work. I still don't know if it works on 648K. Maybe. It's doing more, it's loading more. There it is. Freaking works. Music and all. Love it. I used to play this game a ton as a kid. It's got nice colorful graphics and everything, of course. Can't show that to you on a capture. If I could grab, maybe I should grab a 1084 monitor. Let me go do that. Let me grab a 1084 monitor. We can just validate that the color is working properly on this thing. Alrighty, it's the next day, and I've reviewed the footage for this video, and this video is pretty much terrible. I had all sorts of technical glitches, like the bench camera just stopped recording, and obviously you saw there was footage and it just cut off. So it did that on its own, and for unknown reasons. It worked the rest of this video. It recorded hours of footage without any issues, so I have no idea why I decided to stop. Also, the focus issues with this camera, it was picking up, I think, on the disk controller card in the computer, so it was constantly focusing on that and not me. I mean, facial recognition, Sony, does that not work? I'm not even sure that's turned on, to be honest, but anyhow, I have the 1084 on the bench here, and let's see how Fat City looks with the color monitor. So I'm gonna reach over and turn that on. There it is. We ended up at the basic prompt. Now, I know there's a shortcut in the machine language monitor to actually do the equivalent of PR number 6. I just don't know what it is, and I did a little bit of Googling, and I really couldn't find it very easily. I'm sure people will put some comments down below to let me know what that is. Oh, and incidentally, this keyboard which I'm using, it's still the same Apple II Plus keyboard here. Yeah, the 6 is working. I kind of glossed over that in the video. It definitely wasn't working originally, but I put a bunch of Deoxit down the key switch, and I just pushed it like 100 million times, and well, not quite 100 million times. That's an exaggeration, but yeah, a bunch of times, and now the 6 is working. So that fixed it. Deoxit to the rescue. Anyhow, let's load Fat City. Hopefully the machine is still working properly, and we get a nice color image with sound and everything. There it is. Yeah, so this computer definitely is working fine now. I sort of tweaked the board, banged on the board, done stuff with the board, and there's no issues whatsoever. The video output on the 1084 is absolutely sublime as well. The colors are vibrant, the text is very sharp. Everything on this machine is working really well. In fact, I'm pretty impressed. I mean, I'm very familiar with Apple II graphics, but we have to consider that this machine came out in 1977, and you could have nice sharp color graphics like that for your home computer in 77, which is certainly heads and shoulders above the TRS-80 and the PET. It wasn't long after the Apple II came out either, due to the fact that this thing has such a nice open architecture that Z80 cards came out for it, 80 column cards, so you could run full CP/M software on this thing, which was, you know, the business application until PCs came out, right, in 1982, 81? Am I forgetting my years? Anyhow, yeah, so it's pretty cool to see this working well, and, you know, off camera I did play it a little bit, and it is working perfectly. This machine is behaving exactly as it should. Why don't we try another game? I have a copy of the game Droll by Broderbund, which I gotta say is a game I really liked when I was a kid. Let's see if this thing works on here. Basically, this is a game where you're a little creature flying around and you have to go find the girl with the balloon, and that gets you to the next level. And it's a pretty charming and cute little game. There it is, Droll. Let's see if I can remember how to play this thing. Okay, so you're this little guy here. Notice it's got scrolling down. Here we go. There is sound. Oh, that's the girl we want. Nope. Oh, and I just died. I am playing at a very extreme angle, so that's causing some of the difficulty here. That's what I need to find to get to the next level. That guy, I don't know what that even is. Anyhow, yeah, the it gets progressively harder as you play more. Like, you get little magnets that float around here. Whoa. And the magnets stick to you and you can't shoot or whatever. So anyhow, Droll, fun. If you haven't tried it, I recommend it. Alrighty, the Apple II is all back together. I've gone ahead and serviced the power supply, but because this video is getting super long, I decided to do it on a second channel video. So watch for that on the second channel if you want to see what I did to service it. I haven't even tested the keyboard. I just plugged it back into the motherboard, and I'm gonna make the assumption that it works. Floppy drive is connected, the monitor is on and connected. Let's see if this thing works. Okay, good, it booted up. I mean, you know, we're at the prompt. Control B. Uh-oh, the keyboard's not working. There was no indicator on the power LED there, and I know I saw that working previously when I first tried this machine. So let me just quickly take a look and see. Maybe I didn't get it connected quite right. The cover is off the Apple II, and I have removed the keyboard from it. And I haven't seen one of these in person. It has this microcontroller right here on the keyboard, a few DSLogic chips, and then this ribbon cable here. Now, originally when I turned on the computer just now, you saw there was no no power light. It's an incandescent bulb. So I put Deoxit on the motherboard and reseated it, and then the light was on, the reset button was working, but none of the other keys worked at all. So on the back side of the PCB here, I used the multimeter and I just checked a couple of the switches, and they are all getting really good continuity, around 1 ohm or less. So I think the key switches are all working here. There's something going on either with the contact on the ribbon cable here, which is in a socket. So I've gone ahead and put Deoxit there, or one of these DSLogic chips is not working, or the microcontroller itself is not working. I'm just making sure that it is in there. Just give it a little push into the board there. It was loose. There's another DSLogic chip there, and I bet you this is a 555 timer. And yes, it is. That would probably be for resetting the microcontroller on the keyboard. So let me plug this thing back into the computer as it sits right here, and let's see if it works a little bit better now that I gave this chip a push and I put some Deoxit on that socket there. Oh, there we go. Okay, reset light's on. Okay, the reset button works, but none of the keys do. Well, I am noticing that I think this ribbon cable is bad, because when I push on it, the light is going off and on, so it could well be that this cable is just no good. And I've had this particular problem before. It's got gold pins on there, so I really don't think that's the issue, but it's absolutely flaky there on the board. It looks like the other keyboard I was using has this encoder board. It also has a removable ribbon cable, so I'm actually going to just give this a little swap just to validate for sure if it's the ribbon that's dodgy or if it's something else on there. So the way this was installed, the stripe was towards the reset key there, so I just need to make sure that I do the same thing on this one here. All right, just like that, it is in. Okie dokie, here we go. At least we got the power LED. Reset works, but nothing else is working. Okay, so that pretty much confirms that we have a problem here on this part of the board. So I think I'm gonna need to have this be repaired in another video as well on the second channel, because I'd like to get this video finished up. All right, the Apple II is back together again, but without the original keyboard, which is sitting right here. So I've temporarily stuck my Apple II Plus keyboard in here, the one I was doing testing with, and the computer is working perfectly. As you can see, booted up into Fat City. No more of those instability issues are present on this system. It is actually seemingly working perfectly, as is the power supply that I serviced, which is in there. Now, one thing is to install the Apple II Plus keyboard, which had that encoder board on the back, meant that there wasn't enough clearance to leave this character ROM switcher thing in the computer. So I took out the character ROM, which I thought was the regular lowercase ROM, or uppercase ROM that is, and I stuck it on the motherboard along with the little 74LS TTL chip that was on the end of that bodge wire. And obviously the system just works perfectly. It's a 2513 character generator ROM, so it doesn't have a standard footprint of a normal EPROM. So yeah, this thing is back together, but I have to give my friend the bad news that this original keyboard is not working. I hope that this video was interesting and was kind of cool to see the original Apple II on the inside there. And it was definitely my first time ever taking a look at one of these machines up close, let alone working on one of them. So a real learning experience for me. So I'd love to hear comments and suggestions about this video and this computer. I will be giving this back to my friend, but I'll have to give him some tips on how to use it, like how to get into the basic interpreter there so you can even load a disk. So please put all sorts of little tricks and tips and things in the comment section. I'd really appreciate it. I want to give a huge thanks to my patrons. Their names are scrolling up the side of the screen. They get early access to videos, plus some behind the scenes stuff, things like that. And I think that is going to be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.